Great, great. So thanks for coming. So my name is William. I'm from a company called Elastic. And it's Christmas today. I have lots of things here. In order to get this, all you need is just to answer some questions, okay? The more questions that you answer, you get gifts, okay? Did you guys get the stickers? Yeah. Stickers? Okay, perfect. All right, so let's start. Let me start with the questions. How many of you have heard something called Elastic or Elasticsearch? Okay, one, that's good. That's a good start. Okay, two, all right, okay. So for those who don't know us, don't worry. So today it's Friday and it's 5 p.m. I'm going to make it interesting for you, okay? So let's start. So I have PowerPoints, I have demos. So if you feel boring about the PowerPoints, just tell me. I'll stop the PowerPoints and we can jump into the demos. So Elastic is a search company, okay? It's an open source search company, okay? All our source code is on the GitHub repo. You can see everything. So we are an open source company. And we are focused on search. So when I say search, what does that mean to you, search? Google search? Web search? Yeah, well, okay, that's a good answer. Okay, there we go. So good answer. You get a t-shirt. All right. So, okay, what else? What else? What else? What else? What does search mean to you? Well, search engine, web search. Looking for an answer from where? From a search engine. Well, come on, it's the same thing. Okay. That's search. Okay, from open source. From database. What is inside your database? Data. Okay, excellent. So you get a t-shirt too. So help me. Oh, sorry. All right, so search is not just about searching your data. It's also about analytics on your data, searching for information, right? Okay, so how many of you have used Uber? I know Uber is illegal in Hong Kong, but how many of you have used it? Okay, so do you know Uber, when you order a car, it's actually doing a geographical search. So it actually searches all the cars around you, and that's actually powered by Elastic. All right? So that's Uber. So when you do address search, that's also Elastic. Okay, Yelp. This one might not be that common in Hong Kong. It's a way to search for restaurants. Again, this is also powered by Elasticsearch. All the search here, whether you want Japanese food, or sushi, or Chinese food, all the search stuff here, again, is powered by Elasticsearch. Okay, Tinder. How many of you have used Tinder? You get a water bottle. Oh, yeah, all right. So the matching process in Tinder, behind the scene, is also powered by Elasticsearch. Okay, so next is going to be even more interesting. Okay, so this one is going to be a little bit tricky. Let me get the water bottle ready. All right, you guys ready? So how many of you are gamers? All right, so Blizzard, they are using Elasticsearch or the Elastic Stack to store all the gaming server logs and monitor all the gaming servers, find out all the players around the world, what is their performance, whether there are any issues on their environment. Everything on the monitoring side is powered by Elastic. All right? Okay, so Indiana University, they are doing cybersecurity. Again, the entire university environment is using Elastic to do cybersecurity monitoring. Okay? All right, so search in our terminology is just a foundation. There are so many use cases. It could be your search bar, kind of like a little, Google search bar. Or it could be data analytics. You have a lot of information. You want to do aggregation on your data set. That's also a search. Find cars, again, is another type of search. We call that a geo search. What else? Machine learning. So we have machine learning that can actually help you to find anomalies within your data set. That's another type of search, okay? Okay, so what is special about Elastic? In the world out there, you probably have heard there are people doing something similar, but what is special about Elastic? Now, the first one is definitely the scale. Now, when we talk about search, what is, now, okay, I don't have that many gifts, but I'll get you a red t-shirt this time. So when you do a search, what is your expectation, like in terms of the response time? Give me some examples. In terms of response time, you type something, what do you expect to come back? Immediate. Okay, so what is immediate in your terminology? Instant. What is instant? In real, come on, we need numbers, right? Milliseconds, you already got the t-shirt, so I can't give that to you. But people have different terminology, like in terms of search performance. Some of them say, oh, I'm happy with millisecond. Some of them are saying, well, I'm happy with hours because I can go home and have a rest and wait for the result to come back. It doesn't matter to me. So it's relative, right? But in our terminology, when we talk about search, we talk about milliseconds performance. Now, millisecond performance is easy when your data set is small, right? But when you're using Elastic, what we talk about is whether your data set is a few megabyte, a few gigabyte, a few terabyte, or even to the petabyte scale, is still milliseconds response time. And the way that we achieve it is through parallel queries. So some of our customers, they start with a few nodes, a few machines, that's what we call it, and they get millisecond performance, they're really happy, and they start to ingest a lot of the data into the platform. And at certain stage, they can have a cluster with thousands of nodes doing the same single search. And that's the scalability that we're talking about here. Thousands of machines running together to search for your data set. And the response time is still milliseconds. All right? Okay, speed. So we talked about how fast milliseconds performance, right? Some people are happy with seconds, but we're not happy with seconds. We are happy with milliseconds, okay? Relevance. So in Elastic or Elasticsearch, there is a lot of ways that you can tune the relevance of your data set. Could be a geographical search. I search how many people are actually in this room. That's one type of search. And we make it relevance to that. For example, how many people in this room are from a CS course? We can do that type of search. You have a question? Okay. All right, so this is the Elastic Stack. So there are a couple of components on this stack, and I will explain each one of them to you. So the middle one is called Elasticsearch. This is where all your data are stored. It doesn't matter whether it's megabyte or petabytes, they are all stored on Elasticsearch. And the way that we scale it is by parallel scaling. So you can start with one node, you could start with your laptop, and all the way to like thousands of machines running together to do a single search for you. That's Elasticsearch, okay? Okay, so besides search, within Elasticsearch, we do other things like metrics. So for example, I need to do an aggregation. I need to count how many people are here and have their phone down and they're looking at the phone. So we do that search as well. And again, this is part of the Elasticsearch engine itself. Okay. All right, so we have more components in the front end to get the data onto the platform. Whether it's from your phone or whether it's from a server, we have a way to get it. So we have something called bits. These are what we call the specialized modules to get different information. So for example, you have a bunch of log files from your server, or you have a lot of servers running different kind of processing informations. We can collect all those through all these bits, okay? Okay, so again, like, because we are an open source company, that makes us like really, really interesting. So at the very beginning, what we've done is we open up the protocol to everybody, the bits protocol, and then people start to like throw in or creating new bits to collect different type of informations. So for us, we maintained about like 10 different kind of bits, but in the community, there are like hundreds of bits available. All you need is download the bits, connect to our Elasticsearch engine, then you can collect different informations, okay? Okay, Logstash. Logstash is another way to get your data onto the platform. So I know it's a little bit quiet now, so I'm going to ask another question, give you guys this red t-shirt. So how many of you are from or have attended a database course? Yep, okay, so you get a t-shirt. All right, so a lot of people are using databases today, right? It could be a bank, it could be whoever. A lot of companies are using databases. But what I can tell you is, in a database, you can do all this sort of like select statement, get back your information, right? However, there is a big, big problem with a database. When you do a search in a database, when the data set is small, it's okay, response time is reasonable, but when your data set is really, really big, searching in a database is really, really expensive. All you usually need is you need to scale vertically on your server, getting more servers in order to do a search. And I can tell you, the database people don't like that. They will say, don't do it in my server. So a lot of the use case that we've seen in the past is people do search from Elasticsearch. So how do they get the data from the database onto Elasticsearch? So you can actually use this Logstash module. What you can do is it can actually talk to your database via like JDBC, and then it can actually regularly schedule to collect the content or collect your database table information back into Elastic. Once the information is in Elastic, then you can do the search, okay? And there are so many use cases that are similar to this. Later on, I might be able to show you some. Okay, last component on the stack is called Kibana. So Kibana is the web UI where you can use it to do your data analytics, to search your data. It's a UI that we built to help you to easily understand your data. Okay, and in the demo, you will be able to see the Kibana. So this is what it looks like. You can do a lot of wonderful things. It could be part of your final year project too, to use Kibana to do your project. So I'll give you some examples later. Now, on the top of all these, what we call the stack, we created a number of solutions. Some of these solutions are what I called a little bit commercial, but a lot of them are actually really, really useful, whether you are on commercial, whether you're a student, or whether you're doing data analytics. So I'll give you some examples. Let's say, I wrote a program. It's really wonderful, right? But it's kind of slow. How can I debug the program? In the past, you may actually, put in some log entries to figure out, hey, which part takes, how much time to analyze the program that way, right? But by the time that you finish all these logging thing, your program is like full of these log lines, okay? So one of the modules that we have is called APM, Application Performance Monitoring. It can actually tap into your program, understand all the libraries that you're calling. Could be, your database call. How long does it take for this, SQL statement to return? Whether it's heavy compared to the others, we can find that out easily. Now, another way to use it is, in today's world, computer program is not just a single program. It's usually this computer calling this, and this calling this, and that, right? So it's a chain of computing, what I call transactions. How do you keep track of which machine is slowed in this entire transactions? It's not straightforward, but you can do that with the application performance monitoring quite easily. So the entire transactions, we can pinpoint exactly which part is slowed in your environment, okay? And we have application search, site search, enterprise search. These are more search related. I will show you a few examples on those as well. So let's talk about loggings. So logs. Now, logging is a really interesting thing. Now, when you say logging, it's just a piece of text from your program, right? But in reality, that piece of text is really, really important everywhere. So that log could means how fast my machine is running, or it could means how many people are hitting my website, or it could means there is an error in my program. So having that information available in your environment, it will help you to figure out the issues that you have in your setup, whether my program is slow or whether it has bugs in my program. You can use that quite useful. So I'll give you an example in terms of where people use this. Let's say Cafe Pacific. So they have a website, this website. Okay, so this website. Now, I'm going to ask another question, so get ready. This is going to be a bottle time. This website, when you order a ticket, guess how many systems are behind this website? How many systems are powering this web page or the entire ordering process? 5. Okay, so I heard 5. 1. Okay, I heard 1.
7.
I heard 7.
More than 1.
Huh? More than 1. Ah, okay, well, that's smart guy, okay. So 7, that's the highest number. 15? Okay. 100, okay. 1,000, all right, good. We're getting there. 5,000. Okay, a little bit lower. Okay, 5,000 is close. 3,000. You got it. So there are 3,000 systems powering this web page. The entire ordering process, how you can get a seat, and you can imagine the complexity here. I still remember 2 years ago when I ordered a ticket, you get an error on their web page. You don't even know whether you can, order is successful or not. So you will have all sorts of problems. And Cathay Pacific also realized this is a problem to them. So they built a kind of like log monitoring platform using the Elasticsearch to monitor all these log informations, whether there are errors from a particular page and all those. And by using that platform, actually they reduce all these problems by something like 90%. So that's the power of having all the data, all the information in your environment, and to be able to do analytics on your data. Okay? Any question? Okay, no question. Good. All right, so this is another example of using data analytics. So NASA, their Mars rover, there you go, Mars rover, is constantly sending data, metrics informations, or kind of like log information, back to the Earth. And when it's arriving Earth, it's using the Elasticsearch to collect all these informations, doing analytics. That's another type of analytics or logging that we're doing. Okay? Okay, infrastructure metrics. So we talked about logs. You can collect a lot of information on your environment. You can do analytics. But log is not just the only thing. You will need other things to complement your logs. So for example, this server is somehow generating a lot of logs, but it's also slow. But how can you capture the slow informations? So in the Elasticsearch, we have a way to capture these, what we call metrics informations. We can tell how busy your machine is, what kind of things your machines are doing, and then you can use those informations together with your logs to figure out where the problem is. So later on, I have a demo that can actually show you how you can go from an application, slow problem, all the way to the logs, the database, to figure out where the exact issue is, okay, using just the Elasticsearch. Okay, so application performance monitoring. We talked about that a little bit earlier. So it's an automatic way where you can actually capture all the application performance informations. Now the most interesting part is actually the next screen. So the one that you will see, there are lots of colors, there are lots of bars. It's showing, oh, that one, this one right here. So it's showing one particular transactions. Underneath is calling many, many different systems. And you can pinpoint exactly which one is slow. So that's not something easy, especially in a distributed world, okay? All right, so we also have security analytics. A lot of people love the Elastic environment because they can do things fast. Now, I'll give you one example. I was talking to the Defense Department in another country. I won't tell you which country. But what they told us is, in their existing setup or environment, when they do a search, security search, they will have to go outside, take a coffee, enjoy the coffee, and then come back, and then sit down and wait for the result. If you're doing security, that's actually horrible. You want the result like right now, so you don't want to wait. And that's what the security people want. And the Elastic Stack, Elasticsearch environment can actually get you that instant performance. And that's why a lot of people actually build a lot of security solution on the top of the Elastic Stack. Okay? Okay, so this is one example. Indiana University is doing exactly that, security on Elastic Stack. All right, so search. Now, I was thinking like earlier how I can show you guys easily about our search power, but what I figure out is maybe just give you some examples will be the easiest. So I'm going to ask the next question. So, ready? Okay, so how many of you have used Wikipedia today? Oh, there you go. Okay, so behind the scene, Wikipedia, search, this little search Wikipedia thing, on the top right-hand side, is actually powered by Elasticsearch. Okay? So when you type something there, that single keystroke will result a call to Elasticsearch. Remember, like when you do Google, right? When you do Google, you type 1 or 2 characters, it will have a suggest list for you, right? Behind the scene, that 1 or 2 stroke kicks. We're talking about less than a second response, right? It actually sends a query to the backend Elastic or backend engine, get back the result, and give you the suggestions. Okay? And this is powered by Elasticsearch. Next. Okay, I have another T-shirt. Okay, ready? So, are you guys ready? So how many of you have contributed code in? No. Okay, hands down, hands down. Okay, ready? Okay, how many of you have contributed code in GitHub? Okay, there we go. So you. Okay, so GitHub, when you do search on the top, right there, again, behind the scene is powered by Elasticsearch. So that's the kind of experience that you get. No matter where you search, you need something fast, and people just love to use Elasticsearch to do searching for you. Okay? All right. So let's do some demos. Okay? So I have 3 more things left. Okay? Actually, I have 3 more bottles and a T-shirt. So let me just get ready for my demo. Okay, so what are you looking at right now? This whole thing that you're seeing is actually Kibana. Okay? So this is where you interact with your data. Okay? Now, I have a setup here. Okay, I'm going to ask more and more questions. Are you guys ready? Okay, so in your experience, how many, what is the best way to ask this? Okay, I don't know what the best question for this. Let's hold that for a few minutes. I will think about that. I'll give that to you. Don't worry. So, how many of you have used something called Kubernetes or know what is a Kubernetes? Oh, okay. All right. So I give you a T-shirt. Photos later. Okay. Okay. So Kubernetes is a way to, in short, it's a way to consolidate your resources, allows you to easily, allocate resources in a big pool of environment. Okay. Now, this setup here is in a Kubernetes environment. We have a few big servers. Under there, we are running many things. In the front end, there is a React module, a Node.js module. In the back end, there is a Spring layer, Java layer. On the right-hand side, there is a Python layer. Left-hand side, right-hand side, there is a Python layer. And then underneath, there is a MySQL server and a Elasticsearch engine. Okay? So this setup is complicated. There are lots of components in the environment. And to monitor something like this is not easy. You have to do so many monitoring on the setup. So what we've done in this demo is we've put in the Elastic Stack on all the different points. So if you look at all these file bits, packet bits, metric bits, other bits, we install all those into the environment, capture different informations, and try to find out what is going on if there is a problem, right? Now, we also put in what we call the APM, Application Performance Monitoring. So all the transactions that's happening in the setup, we'll be able to capture it, know what is going on, whether there's anything abnormal, and figure it out, okay? Now, let me show you what we find, okay? So in this setup, there is a problem. So machine learning, we talked about earlier, there is something called machine learning. And this machine learning thing, what it will do is it will capture or find out anomalies in your program or in your performance. So right now, we've hooked up our APM into machine learning and say, okay, typically my application works like this, but if there is something abnormal, we will be able to detect that automatically for you. And right now, we find out there is a problem in the server. So click on this link. It will bring you to one of our dashboard. It's the machine learning dashboard. Now, this machine learning keyword, I don't know whether you guys have a course on that or not, but it's a word that we hear every day. Now, but what does that really, really mean to you, right? So now I'm going to ask you guys another question. So on this screen, what do you think is important? Just tell me a color. Well, you got the bottle already, so can't. At the red. Yeah, so if you see something like this, well, hey, red is important, right? So what is happening? So usually what people do is when they see something like this, they click on this and they find out, aha, so there is something wrong here. But what does that mean, right? So we actually use machine learning to keep track of what we call the transaction time. Let's say somebody call your website, could be your eBay, could be Alibaba, and try to buy something, right? But it takes so long to return. Normally, it takes milliseconds, but this time it took like a few seconds. So how can I find out what is going on, right? So this machine learning will be able to find the information for you. So now that I know there is a problem, what can I do, right? So we have a way to hook up different analysis to start troubleshooting your problem. So the first one is what we call the APM analysis. Now, is this low because I have a lot of transactions or because of something else? I don't know. So I can go to the APM analysis to find out more. Aha, okay, so on my left-hand side, also on your left-hand side, so this is showing what we call the transaction time. So there is a big spike here, right? But what does that mean? Is it because of I have a lot more transactions? So if I look at the right-hand side, I don't see any problem here, right? So my number of transaction or requests is regular, but somehow the transaction duration is really, really long. So what can I do? Again, in our APM, what you can do is you can actually zoom into the individual transactions to find out what is going on. So I can click on that particular transactions. Again, I see the same problem. Some of these transactions are really slow around 8 a.m., okay? But the request per minute is not much more, okay? Here, I actually have a distribution in terms of my transaction time. Normally, it takes about 100 milliseconds to return, but somehow, go back. Sometimes it could be as slow as close to a second. In order to try to find out what is going on, you can click on these, and it will pull a sample of your transaction. And then you can see underneath, it's doing a lot of database select statement, okay? So right now, there is a lot, but I don't know what is going on, and I couldn't figure out whether it's a particular one that is slow. So if that one is slow, you can actually click on it, and then you can actually see the entire select statement. Now, all these, you don't have to do anything. All you need is hook up the application performance monitoring to your program. You get this automatically, okay? So go back. The first thing that people normally do is compare a regular transaction to a slow transactions to see whether there is anything that you can find. But in this example, you can't find much. There is something going on, but it's not very obvious, right? Okay? So you can start the next investigation. So here, there is a service analysis. Now, what is a service analysis? It's just a way to show a service in terms of the response time. So open that dashboard. What you will see is there are lots of information here, lots of dashboards, right? But what does that mean to you? Usually, people look at this and they shake their heads. I don't know what is going on. And the interesting thing about this particular dashboard is it's using many, many informations. So look at this one. It's using application performance monitoring informations. Go down a little bit more. It's using another one called file bit informations. And all these markers, we actually use machine learning to collect or send out or create these alerts. So when there is a problem, you can actually zoom in and find out whether there is anything odd here. So look at this part here. So compared to the previous screen, you will see there are lots of red thing, orange thing here. And I can tell it's because some of the client and servers are kind of busy when the problem occurred, but not the address finder. So you can start to isolate where the problem is, okay? So this is, again, I find out more information, but can I solve the problem right now? No, right? Okay? So next step, go back. I'll do the next level analysis. This time I'm going to look at the infrastructure. So infrastructure meaning from my big servers, from my different applications, I want to find out whether there's anything wrong. So click on this, and you see there are some blue thing. So what is that blue thing, right? So these blue, or these boxes, they are a machine, a physical server. So right now, I can tell this physical server is a lot busier than the others. Now imagine that you have 1,000 of these servers. You want to find out which one is more busy compared to the others. All you need is just open up this page. You'll be able to see it, okay? Now, I know the server is busy, but what else can I find? So Kubernetes, the infrastructure is kind of like in a, what we call the pod environment. So everything is in a pod. It's a group of resources. And I can see, somehow this guy here is a lot busier than the other ones. And it's a MySQL module, 28 QGT. And then, okay, so let's write it down, right? And then we'll start investigation from that end. And then look at the Docker. So Docker is the next level behind the pod concept. So you have resources, you have the individual Docker that compose of your pod, okay? And then you can also see the similar behavior. So there are some pods or some Dockers and setup. It's really busy compared to the others, okay? So now that I know there's something wrong or potentially wrong with MySQL, so I can now use the MySQL related information and zoom into the problem and find out whether there is anything related in that area. Okay, so next step, I'm going to open up the dashboard for MySQL. So I'm going to find out the MySQL dashboard, and I'll do a MySQL analysis. So I'm going to ask one more question to you guys. So if somebody can answer, you can get a bottle. Okay, so remember in the previous screen, I said something about the MySQL. I said there is one number. Something is wrong with that particular pod or Docker instance. I actually said 28 something. If somebody can answer the last 3 characters, 28 something, you get a bottle. I know this one is going to be difficult. Oh, there you go. Somebody can actually remember. That's excellent. So it's 28 QGT, not GQT. But so let's find out what is going on. 28 QGT. Let's zoom into that particular pod and find out whether there are any performance issue around that time frame. Aha. Okay, now that I'm zoomed in, I can see in terms of performance, there are spikes happening for that particular pod. And I can even see when there are issues, what is running in the server. Okay? So I'm going to zoom into that particular window, and I still have 2 more water bottles. And right here is showing you what is running at that time. So my question to you is, can somebody guess when there is a performance problem, what is running? But before you answer, hold on. The hint is actually one of these things. Okay? So any guess? When there is a performance problem, what is running in my server? And the hint is one of these processes. So I'm going to zoom into that window, and then you will be able to see what is going on and what exactly happened when there is a performance problem. So anyone want a bottle? Huh? APT compact? No? Okay, good guess, but no. MySQL. It's good guess, but no. DB backup, there you go. But you already got a... You didn't? Okay, you got it. So let's zoom into that window, and then you will be able to see exactly what is happening. There you go. So the DB backup was actually causing the system or the query transaction time to increase. So step back. Somebody reported, or our machine learning find out somehow the transaction is slowed, and we use the logging informations, metrics informations, what is running in your environment to find out exactly what the problem is. So that's the power of having all the information in a single environment. I can tell you, today's world, if you talk to any other companies, they will have hundreds of systems doing all sorts of monitoring. Each one could be doing something. And when you are the one that troubleshooting a problem, I can tell you the scenario. Somebody is complaining. All your bosses behind the scenes, or actually behind you, will say, hey, what is going on? Can you fix the problem? And when you have that kind of pressure, you will ask other people. You could ask a database person whether there's anything going on. You will ask operating system admin to see whether there is other things going on. And you could ask application team whether there is anything going on. And I have one last bottle. Guess what the answer that you will get back from all these different people. Is it their problem?
No, it's not.
It's not their problem. So the next question is, so all these people say it's not their problem. So who is the problem? So a lot of people behind you, user is never a problem. They are always the one that, they are the one that pay and they are not. So you are the problem. There you go. Yeah, so that's the reality. So when you are the one holding the problem, you ask the other people, they will always come back and say this is not their problem. And you are always stuck with the issue, okay? And having all the information, on your hand, you will be able to find out exactly what is going on, okay? So that's the power of having all the data, especially real-time data on your hand, okay? So I'm looking at the time. I think we might be able to do one more demo, so I'm going to make this one quick. Okay. Let's do a simple one. So this one is a little bit more related to you guys, because it's a local Hong Kong map, right? So in the Elasticsearch, we can actually, we have map function. So you can actually use the map to show you real-time data analytics on the map. So what I've done earlier in terms of setting up the demo is I actually go to the government public data website. So they have all kind of data. It could be where the post boxes are, or where a particular car park has any space. You can get all those informations real time on their website. So it could be a form of a CSV file, or it could be a database connections, or a web service call. So you can get those informations from the what we call the public data website. So what I've done in this example is I go there, download the post office post box location informations. So I pull a CSV file and then put it into the Elasticsearch, import it, and I converted all the geolocation information onto the environment. So here you can see all these red dots is showing you where the post boxes are. Now, one thing that is really, really useful is, so for example, look at the location here. It's just a bunch of numbers, right? So people don't like numbers, except their bank account numbers, right? So what you can do here is you can actually say, okay, besides the location informations, so I can actually add in address informations. So I've done that, and look at this. Okay, so you can immediately see the address location informations. And if this information is a moving car, if you're doing real-time tracking of all the cars, trying to ingest the real-time information onto the platform, you can actually have a real-time dots moving on this map if you want, okay? Now, earlier I was talking to one of my colleagues, and we actually have a really interesting conversations, but I don't have any more gifts for you guys. So somehow, look at this. What we find is, in Changzhou, there are 4 post boxes, but in here, what is this location again? Lama Island. There is only one. What is the reason for that? Is it because of a population, or is it because of convenience? So we don't know. So having the data available to you to do analytics is actually really, really useful. You can ask a lot of questions about your data and be able to answer it reasonably well if you can. But something like this, we don't even know how to answer it. But think about this. If you can overlay the population on the top of the map with the post boxes informations, you can probably find out more information about what is happening with your data set. All right, so I'm done with my demos. Do you guys have any question for me? I don't have any more bottles. Any question? How big is Elastic? The company itself. Okay, that's a really good question. When I started about 4 years ago. We only have 200 people worldwide. Now we have about 1,600 people worldwide. Yeah. So we are not really, really big, but we are what we call a distributed company. It's a really interesting business model. We don't go to the office. Every one of us work from home. Well, some of them do go to the office, but usually. How do we talk to each other? Yes. So we actually use video calls. So when we do meetings, we just do video calls. Yeah.
How did you come up with the name Elastic?
Good question. I don't remember the whole reason why we have the Elastic word, why the company is called Elastic. It started from Elasticsearch. So one of the first core product is called Elasticsearch. It's a search engine. And then when we formed that company, we shrink it to Elastic. Yeah. Excellent question. Elastic is an open source company. So everything is open source. You can actually download it from our website. A lot of the modules is free. There are some features that you need to pay, but those are really for commercial purposes. So as a student, feel free to use it. Yeah.
How do you compare this company with other cloud services such as Google, Cloud, and
Yep.
AWS,
Yep.
or
Yep. That's a good question. So Elasticsearch as a service, we do offer our own cloud service. But we run it on the top of AWS, Google, Azure. So we kind of like complementing each other. In fact, we are actually partnering with Google. We kind of like the mini Google and help them on some of the use cases. Yeah. Yes? Do we provide internship? We do, but I don't know whether we have internship in Hong Kong yet. Yeah. What is the problem causing the delay? Yep. Yep, so if there is a problem with one of the transactions calling an external system, and you will be able to automatically see it in the APM side, yeah. Any other question? That's a good one. So this thing here, it's a cluster. So it's a number of machines working together. So usually, like I said earlier, Elastic machine does not work alone. They always work in a cluster format, and we have like thousands of clusters or thousands of machines running together in a single cluster. Yep.
Security analysis.
Yep.
It's like a user-based service, right? So user have to find a log and all the infrastructure.
Yep.
And then you find a social map.
Yep.
The map is online resources.
Correct. Yeah, so the Elastic Stack in the whole thing, it's a couple of layers, right? The first layer is how you can take the data onto the platform. So that's the bits and Logstash layer. And then in the middle, where you store your actual data, that's Elasticsearch. And how you can actually manipulate or view your data, that's Kibana. That's the entire Elastic stack. Any other questions? Bits. Yeah. So bits are just a easy way to collect your data. So for example, you have log files on your server. You want to take the log files, ship it to Elastic. And the way to do it is using the bits. We have a bits dedicated for that purpose to collect files from your server. So it's just an easy way to help you to collect information. Yeah. Okay, so what is my job? Yeah, so my job, I usually help companies to architect their systems and talk to them in the meetings, just like this. And more like from a technical side, give them guidance on how to use the environment or use the Elastic Stack. I can't hear your question. Okay. So the question is about, if I have a startup, can I use the Elastic technology to build something for free? And the answer is yes, you can do it. It depends on the kind of software or whether it's open source or commercial. If you're using open source, you can actually do that. In fact, there are lots of companies are built on the top of the Elastic. Yeah. Any other question? Well, if not, thanks everybody. Thank you.